Hello dear students, welcome to Target. In this video, we are going to start Unit 8 of our AP Physics 1 exam, which is fluid. As we already know that this unit carries almost 10 to 15% weightage of our exam. So let's see what is our syllabus for this unit. Here they have given us 4 major topics. So these 4 topics we will cover completely, means you need not to go anywhere. Whatever I will give, I will provide you worksheet, I will provide you MCQs, FRQs, everything including test also. So you can just rely on my channel and that will be very helpful to you. So I will make like 5 videos here. First and second video will be on pressure. So first video like this today one. Next video I will discuss about the Pascal's law. Third video will be on density. So and fourth is on this Newton's laws. So here we will discuss about Archimedes principle. Fifth is our conservational laws. Here we will discuss about equation of continuity and Bernoulli's theorem. So on almost these 5 videos I will try to complete the syllabus of fluid, and length of each video will be like 25 to 30 minutes maximum. I will try to solve MCQs and FRQs also in each video so that you will have some idea how to attempt them. And as you can see here in the first video I have taken all these MCQs. So let's start. First thing, what is fluid? So sometimes we get confused. Whatever is our general understanding is that we think that okay, any liquid is fluid. That's right. All the liquids are fluid, but gases are also fluid. Always remember this thing, that gases are also fluid, because in physics definition of fluid is anything which can flow. Anything which can flow is fluid. So we know that liquid and gases both can flow. So both of them we will consider as fluid. It means whatever, just like Bernoulli's theorem, we apply Bernoulli's theorem for liquid also. Same Bernoulli's theorem is applicable for gases also. So just like aeroplanes, they are flying. So same Bernoulli principle we will apply on aeroplanes. Now, this branch of physics which deals with this fluid section, we divide it into two parts. First one is called hydrostatics. In this one, we will discuss about the fluid which is at rest, and other one is about hydrodynamics. Here we discuss about the fluids which are in motion. And whatever we are taking here, whatever fluids we are considering here, all of them are non-viscous. Non-viscous means we assume that here no friction is present. No friction is present among layers of fluid. So in general, if whatever fluid you will take, there will be some friction among the layers of fluid. Just like you can understand like this. Let's say this is our first layer. Now this will be our second layer. This will be our third layer. So in between these layers there will be friction. There will be friction. It's the reality. Just like we have air friction, here we will have friction. But we are considering here that whatever fluid we are taking, that is non-viscous. There is no friction present among the layers of fluid. And what is next thing? The fluid must be incompressible. Means its total volume will be constant. What do you mean by incompressible? Incompressible means volume will be constant. I hope this much is clear to all of you. So this is the basics about fluid, right? So fluid are not only liquids, they are both liquid and gases. So same principles will be applicable on aeroplanes also, whatever you will apply on boats. Now non-viscous means no friction is present among the layers of fluid, and incompressible means their volumes will be constant. Two branches, hydrostatic, hydrodynamics. Hydrostatic we will discuss only about fluids which are at rest. Hydrodynamics we will discuss about fluids which are in motion. Now next topic is pressure. Let's start. So what is pressure? Before understanding pressure, let's have a clear understanding about what is thrust and what is force. So basically, if I ask about force, so you will say that force is nothing but a kind of push or pull, right? So if I say you that this, let's say this is a wall, and you just punch the wall in this direction, so it is a force. Yes, it will be a force. You punch a wall in this direction, it will be a force, and you punch the wall in this direction, it will be a force. It means all this ABC, they will be considered as force. All these are force, right? No problem. But if I ask about thrust, so only B will be thrust. Why? Because thrust is nothing but the force which acts perpendicular to the surface, that is called thrust. So when force is perpendicular to surface, that's called thrust. Got it? So whenever we will discuss about pressure, we have to consider the term thrust, not force. Sometimes we use them, like no problem, but we have to clear that whatever force we will be using in pressure, that must be perpendicular to surface. Okay, this much is clear. Fine. Now what is pressure? So pressure, if you have to define, pressure is nothing but thrust over area. Pressure is nothing but thrust over area. So let's say on this surface area, you are applying you are applying this thrust, and area is A, thrust is F. So here pressure P will be F over A. I hope this thing is clear to you how this formula come. Pressure P will be F over A. Correct? No issues this much till now. Fine. Now what if you are applying this thrust not in this perpendicular direction? Let's say this time on the surface, you're applying thrust like this at angle theta to the vertical. At angle theta to the vertical. Let's say this force is F. Now it will be considered as a force, not thrust, because it's not at perpendicular to the surface, and area is still A. So if we take component of this force over this perpendicular direction, so we know that here cos will come, F cos theta. So now this time pressure will be F cos theta over A. So I hope this thing is clear to all of you. How to write basic equations for pressure, right? Pressure will be F cos theta over A in this case. Fine. Now what is unit of pressure? So unit of pressure, obviously we can see that what is unit of force. So unit of force will be nothing but Newton, and unit of area is meter square. So pressure unit will be Newton over meter square. Now what is its standard unit? So SI unit will be Pascal. So this thing we can memorize that its SI unit is Pascal, and a normal unit is Newton per meter square. So I hope this much the basics about pressure is clear to you, that here we will have to use the term thrust, not force, and thrust is nothing but perpendicular force only. So whenever they will give you perpendicular force, like in this case, you can directly use it. But whenever they do not give you perpendicular force, you have to take its perpendicular component. Now let's just read about it. So they are saying that pressure, the normal force means thrust only, exerted by liquid at rest on the given surface in contact. So the normal force exerted by liquid at rest per unit area of surface in contact with it is called pressure. Fine, we already know this thing, that pressure is nothing but force per area, and this is our formula here finally. So I will suggest all of you to keep on making notes along with also me. So if you have your own notes, that will be helpful at the end. So just like from here, means you should always like pause the video and write down everything, and make sure you just draw all these diagrams, all these things, all this theory you need to write. So at the end, if you have good notes, that will be really helpful. Now one more thing, that if you want to uh, take some personal classes, or you want to just have some personal sessions, one-to-one sessions, you can join the WhatsApp community link I will give at the description. And also you can directly message me on my number, which is +91 89177999342. So on the if you join the WhatsApp community, so there you will get this lecture notes. Also you will get worksheet. So, and whatever doubt you have, you can post your doubt there, and you can comment your doubts here also. I will solve them. So doubt resolution facility is also there. Also, I have made one website for this EP Physics. It's like epPhysicsResources.org. So you can go through this website also. I will share the link at the description. So now let's discuss about what is atmospheric pressure. Just think. Let's say, what is atmospheric pressure? Try to understand in the like layman terms. What is atmospheric pressure? Let's say you are here on the ground. This is ground, and you are standing here. Now just think, above your head, above your head, we know that we have this atmosphere up to 32 kilometer. We have atmosphere, and in atmosphere there is air, and air has some mass, right? Air has some weight. Now we already know this thing. So all this weight of air is acting on the surface of your head. Got it or not? So this pressure which is applied by the weight of air, this is called the atmospheric pressure. This is called atmospheric pressure, which is applied by the weight of air. Got it? Weight of air is basically our atmosphere. Any doubt? I think this much is clear to you. So its value is basically atmospheric pressure value we denote by P naught. Its value is 1.01 into 10 to the power 5 Pascal. So this is the value of atmospheric pressure, which is 1.01 into 10 to the power 5 Pascal. Now, what if you want to calculate total pressure inside this setup? Let's say this is a lake. Let's say this is our lake. And you want to calculate pressure at this point. So here the total pressure will be, pressure due to this atmosphere, all this atmospheric pressure, plus pressure due to this fluid also. All this fluid also will exert pressure here. I hope this is clear. So at this point P, the total pressure will be, here total pressure will be P total. I can write, it will be P atmosphere plus P fluid. Due to this atmosphere, this red one will have pressure, plus due to this fluid, this green one will have pressure. Correct? Now, how to write the equation for this total pressure? So I can write here P total will be P atmosphere plus P fluid. Now what is P atmosphere? We already know that we can write it P naught, and its value is almost 10 power 5 Pascal. Now what is P fluid? Let's say the density of this liquid is rho. Density of this liquid is rho, and we already know gravity is G, and this point P is at h depth from this height. From the surface of lake, it is at h depth. So this will become rho GH. So you need to memorize this thing, that at h depth from the height, pressure becomes rho GH. At h depth from the height, pressure becomes rho GH, where what is rho? Rho is density of fluid. What is G? G is, we already know that G is almost 9.8 meter per second square gravity. And what is H? H is our depth from the surface. So I hope this much is clear to all of you how I have written this formula. So total pressure will be P naught plus rho GH. So let's discuss, let's read about this atmospheric pressure, what they are saying. Please keep on writing all this stuff with me, correct? Pause the video, write all this stuff. What is atmospheric pressure? The gaseous envelope surrounding the earth is called Earth atmosphere, and it exerts the pressure which is 1.013 into 10 power 5 Newton per meter square or Pascal. Fine. Now there is this point. When you go above the surface of earth, as you go above the surface of earth, this atmospheric pressure will decrease. If you go above the surface of earth, this atmospheric pressure will decrease. So we can keep remember this point. Now let's see this point number 6. Here they have given us three vessels A, B and C. Here they have given us three vessels A, B and C. And in each vessel there is some fluid, and density of fluid is rho. Density of fluid is rho. The height of water column in each one is h. Height of water column in each one is h. So you can see that height is same. Okay, fine. Now what will be pressure here at the end point? If you want to write PA, PB and PC, so we know that PA can be written as here. PA can be written as P naught, which is atmospheric pressure, plus rho GH. Fine. Where H is this height. H is basically this height, and H is same for all of them. That's what given here. Now what will be PB? So pressure at point B will be again P naught plus rho GH, and pressure at point C will be again P naught plus rho GH. So you can see that pressure at each point is same. It means we can say that pressure does not depend upon the shape of vessel. Pressure does not depend upon the shape of vessel. Got it? Neither it depends upon the cross sectional area. That's what is written here. Independent of amount of liquid, shape of vessel or cross section area. It only depends upon height. So I hope this point is clear to all of us, that pressure at the bottom of each vessel will be same. Now what is our seventh point? Here if you see, all the vessels have different shapes, but they are on the same level. All the vessels have different shapes, but they are on the same level, A, B, C, D and E, right? So here water will rise to the same height in all the vessels. This is our concept. In all the vessels, water will rise to the same height. Why it's like that? Because water rises only, means let's say you have these two vessels. Let's say you have these two vessels. First one is completely filled and other one is totally empty. If you join them, so they will have water up to the same level of height, because water flows due to pressure difference, right? Water flows due to pressure difference, or any liquid flows due to pressure difference, and pressure only depends upon height. So this liquid will flow in all the vessels until the pressure will be same. So here if you think, this pressure at point A will be equal to point B, which is equal to point C, point D and this E also. So pressure at bottom of all these vessels will be same and height will also be same. So I hope this point is clear to you, that water or any liquid flows due to pressure difference, and pressure will be same only when height is same. So here in all the vessels, height of fluid will be same. Now it's already been asked in AP Physics last year, this concept. Now next thing, there is a small term which we said gauge pressure, right? So what is gauge pressure? As we know that this is our container here, and in this container if I ask you to find pressure here at H depth, you will write pressure PS, P atmosphere plus rho GH. So this P total is equal to P due to atmosphere plus P due to height, right? What if I ask you to find pressure only due to fluid? So pressure only due to fluid will become P total minus P atmosphere, which is nothing but rho GH. So this pressure which is due to only height, it is called our gauge pressure. So sometimes they use this term in our exams. Earlier this fluid was in AP Physics B, or sometimes we say it AP Physics 2. Now they have shifted it here. So in AP Physics B, they have asked all these questions which I will take now, and we have to solve them because they will not make like this new type of problems, right? They will simply copy paste problems from there on. So I hope now this gauge pressure is clear to all of us. Now we'll solve few questions. Before solving few questions, let's just discuss one more small concept, which is our shape of fluid. Shape of fluid. Now always remember one thing. If you take this bucket and let's say it's filled with water. In this bucket, what is the net force acting? Net external force is know that it's gravity only, right? What is net external force? It's gravity. And what is its surface? Its surface is this one. So can we say that surface is making 90° with the net external force? It means surface of fluid is always perpendicular to F external. I hope this thing is clear to all of us, that surface of fluid is always perpendicular to F external, as you can see in this example. If I ask you that we have this container or a truck which is moving forward with, let's say, velocity v and acceleration e, and fluid is inside the container like this. Now when this container is moving forward, what will be the shape of fluid now? Initially the shape was like this. Now this container is started moving with acceleration e. What will be its shape? So let's try to figure out what the external forces are acting on this fluid. So we know that on this fluid, first external force is mg, its own weight, basically gravity. And second, because of this acceleration, a pseudo force will act here. All of us know about the pseudo force, right? If you don't know, please comment, I will explain there. Pseudo force is basically if this vessel is going forward with acceleration a, inside the vessel, whatever objects they have, they will experience a backward force. That's called the pseudo force, ma. So now here we have these two forces. So obviously net force will be in this direction. ma is backward, mg is downward, so net force will be in this direction. I hope this is clear. And as of just now, we have studied that surface of fluid is always perpendicular to F external. So F net is in this direction, so obviously surface of fluid will be perpendicular to it like this. It means all this fluid will now looks like this, in this shape. That will be the shape of our fluid. I hope this thing is clear to you. It's already been asked in AP Physics B once. So make sure you note down everything, and it's really a good concept. Now let's try to solve these PYQs. Every question I have taken, again I'm saying this thing from AP Physics 2 exam, AP Physics B. Earlier they used to ask fluid in AP Physics B, so I have picked up questions from there. Let's try to solve them. So they are saying that in the open manometer shown, water manometer is nothing but simply a device to measure pressure. Water occupies a part of the left arm from a height y1 to a height of y2. Okay. The remainder of the left arm, the bottom of the tube, and the right arm of height of right arm to a height of y3 are filled with the mercury. Fine. So basically here upper side we have water, and all this place we have mercury. So let's see what they are asking. The pressure at a height y3 is the same in both the arms. Okay, at a height y3. Let's see. So this is our, let me just use it darker pen. This is our height y3, right? Figure out, think about these 2 points. In the left one, we have all this water, but in right one, we have nothing, only air, right? So in left one, if I want to write pressure here, so pressure in left will be, in left pressure will be P atmosphere plus rho gh, right? Because here we have pressure due to atmosphere plus pressure due to this liquid. But in right one, pressure will only be P atmosphere, because here we have no fluid. Got it? So only P atmosphere is there. So it means pressure at height y3 is same in both arms. It's wrong. Actually, in the left arm it's more, because it's P naught plus rho gh, and in the right arm it's less. So option 1 is wrong. Now let's check about option 2. Pressure at a height y2 is same in both the arms. Let's see it. So this is our height y2. This is our height y2. So in this height y2, let's take this 2 points. Now how to check it? Listen, very important concept. If you see the upper part, so upper part we have different fluids, different height. Water is up to this height, mercury is only up to this height. It's difficult to calculate. But if you see the lower parts here, lower parts have how much? Same height, right? It means lower parts has same height, and we already know that, let's say here pressure is P. So this pressure will decrease as you go upside, right? This pressure will decrease as you go upside. It means on both the side, because this height is same, these 2 points, these two blue points are at the same height from this lower level. So there will be same decrease in pressure, right? There will be same decrease in pressure. So pressure at height y2 will be same in both arms. This will be a correct option. In the same way, we can also say that the pressure on this black levels will be same, right? Pressure on the black level will be same, correct? It means pressure at this point will be equal to pressure at this point. Now let's say this point is A, this point is B. So can we write PA is equal to PB? Yes, we can write. We know that pressure on the same level in a liquid which is at rest must be same. Now what is pressure at A? So we know that pressure at A will become P naught, which is atmospheric pressure, plus rho GH. What is rho for glycerine? I think it's given in the question as 1.3. What is G? G we are taking as, let's say G I am writing as G only. And what is height of glycerine? It's 10 centimeter. On right hand side, what is PB? In PB, if you focus, here we have two different liquid. First one is oil. So first pressure is due to atmosphere. Second is due to oil. What is density of oil? Again we have to write rho GH for oil, right? What is density of oil? I think it's 0.8 given in the question. G I am writing as G only, and H is given as H here. Plus, now I need to write rho GH for this part, and we know that this much is oil, mercury here. So at point B, pressure is due to three things. First is due to atmosphere, second is due to oil, and third is due to mercury. So due to mercury, pressure will be again rho GH. What is rho? Rho for mercury is given as 13.6. G I am taking as G. And what will be H? H for mercury will be, if you see by the diagram, obviously this will come as 10 minus H. For mercury, height will come as 10 minus H, correct? So it will be 10 minus H. Now let's try to solve it. P naught and P naught will get cancelled. And after this we have this G, and both the sides G will also get cancelled. So here we have 1.3 into 10, basically 13 is equal to 0. Into H, 0.8 H, and this side we have 13.6 into bracket 10 minus H. So let's try to solve it. It will become 13 is equal to 0.8 H, plus 136 minus 13.6h. So how much it will come? Then it will come 13.6 minus 0.8, basically 12.8h is equal to 136 minus 13 will come 123. So from here h will come almost 9, right? If you solve it, h will come almost 9 centimeter, because it's almost 13, so 13 into 9 will come 127. So here option D will come, right? 9.6 centimeter. So you can use calculator and you will get the exact answer as 9.6 centimeter. I hope this question is clear to you. It's really a good problem we have solved here. Now let's try to solve the next sixth question. Three liquid of vessels of equal masses are taken in three identical cubical vessels A, B and C. Densities are rho A, rho B, rho C. Okay, fine. They're asking us four. So we know that uh, how to solve it. Just go by the basics. Pressure is force over area or thrust over area. Force can be written as pressure into area. Here they are saying that identical vessels. It means area must be same. So can we say that force is proportional to pressure? And we already know pressure formula is rho gh, which means force is proportional to pressure, and pressure is nothing but rho gh. So pressure is proportional to density. Correct? Now here for liquid C density is maximum. So for liquid C density is maximum. So for liquid C pressure will be maximum, and for the same liquid C force will also be maximum. I hope this is clear to all of us how we have concluded it. Pressure is nothing but thrust over area, so thrust will be pressure into area, right? Now identical vessels, so pressure area will be same. It means force is proportional to pressure, and again pressure is proportional to density. So option A will be correct. Now let's see problem number 7. A given, first all of you try it yourself and then see the options. Just pause it, try it yourself and then see how I'm solving it. Given shaped glass tube having cross section in a is filled with water and is mounted on a rotable shaft as shown in the figure. If the tube is rotated with a constant angular velocity omega, then water level in both sections A and B go up. Listen, how to solve this question? We know that when this tube will go up, just apply some logic. All this part of fluid will try to move in this direction, correct? And this side part of fluid will try to move in this direction, and further they will send this water upside. Got it? Why it's, and one more thing, why this part of fluid tries to go up rightward? Because of the centrifugal force. And this centrifugal force further will push this water upward on both the side. This side of water is also going to move leftward due to centrifugal force, and they are trying to push this water level upward in both the arms. It means water level in both sections A and B will go up. So option A will be correct. I hope this is clear to all of us that due to the centrifugal force, the water in the horizontal arms will go towards the left and right, and further they will increase water level in A and B. I hope this is clear. Now here I have given you one problem to try yourself, and if you understood this problem 5, I think, yeah, problem 5 properly, you can easily solve it. So I suggest all of you to try this problem and comment what answer is coming in the comment section. Again, this is our first lecture on this fluid, right? I will make 5 such lectures here, and for practice worksheet and the lecture PDF, try to join our WhatsApp community, and which link I will give in the description. For any personal mentorship, just message me here in WhatsApp community. Also you can find my number. Try to visit my website. I will give link in the description. You will get all the MCQs, chapter wise notes, FRQs, everything there. This is our class notes, right? Class notes you will get in the WhatsApp community. And for lecture like topic wise notes, topic wise MCQs, topic wise FRQs, you can visit my website. One more thing, website if you will visit, no, so you have to visit in the desktop mode, right? Means try to visit in the laptop only, not in the phone, because it doesn't work good in the phone. I just made it myself. Content is like A level, but you need to watch it in our laptop only. And whatever doubts you have, you can comment here. You can comment in the WhatsApp community. You can comment directly in. You can simply directly message me. Okay. So next lecture I will upload tomorrow, and next lecture we'll discuss about Pascal's principle. So next lecture we will include FRQs also, right? Okay then. Thank you so much.